Do you ever wonder if electric vehicles are as safe as they claim to be? It's a question that's on many minds, especially as we see a few high-profile fire incidents involving electric vehicles making headlines. These incidents can sway public opinion, making us question the safety of these futuristic machines. However, it's crucial to understand that these concerns might actually be misplaced, and the actual safety of electric vehicles, or EVs, is far more nuanced than it appears at first glance. Electric vehicles and their traditional internal combustion counterparts undergo the same rigorous crash testing procedures to evaluate their crashworthiness and occupant protection. These tests are conducted by reputable bodies like the National Highway Safety Administration's New Car Assessment Program and the Insurance Institute for Highway Safety. These analyses use crash test dummies representing mid-size male and small female occupants to evaluate the risk of injuries. The tests also take into account the fire hazard, either caused by thermal runaway, a scenario where lithium-ion batteries experience rapid, uncontrollable heating in ruptured EV batteries or gas tank leaks of internal combustion vehicles. Interestingly, none of the Insurance Institute for Highway Safety crash tests of EVs have sparked any fires. Similarly, New Car Assessment Program crash test reports yield comparable findings. While real-world data analysis on vehicle fires involving EVs is limited, it appears that media and social media scrutiny of EV fire hazard is blown out of proportion. It's like focusing on a single tree while ignoring the forest. The safety of electric vehicles isn't as straightforward as it seems. Let's delve into this further. That's what we'll be doing in the coming sections. So stick around as we unpack the safety dynamics of electric vehicles and separate fact from fiction. When it comes to crash testing, how do electric vehicles stack up? Let's take a closer look. Crash tests are an essential part of safety evaluations for all vehicles, electric or otherwise. They utilize crash test dummies to represent different types of vehicle occupants, ranging from mid-size males to small females. These dummies help us understand the potential injuries that could occur during a crash, providing invaluable data that can be used to improve vehicle safety. When it comes to electric vehicles, there's a specific concern that needs to be addressed: the risk of fire hazards. These are typically caused by a phenomenon known as thermal runaway, which occurs when lithium-ion batteries experience rapid, uncontrollable heating. This can happen when the battery is damaged, such as during a crash. It's a concern unique to electric vehicles, but is it a valid one? Well, let's look at the evidence. The Insurance Institute for Highway Safety, a respected authority in vehicle safety, conducts extensive crash tests on electric vehicles. To date, none of their crash tests have sparked any fires. That's right, not a single one. But what about the New Car Assessment Program, another key player in vehicle safety? Their crash test reports yield comparable findings. In other words, they also found no significant fire risk associated with electric vehicles. So, if the experts aren't worried, why is there so much talk about EV fire hazards? It seems that the scrutiny surrounding this issue is largely driven by media and social media, rather than hard facts. In reality, while the data on vehicle fires involving EVs is indeed limited, it doesn't suggest that electric vehicles are any more prone to catching fire than their internal combustion counterparts. In conclusion, when it comes to crash safety, electric vehicles are holding their own. They undergo the same rigorous testing as other types of vehicles, and have thus far shown no significant increase in fire risk. The media scrutiny of EV fire hazard seems to be blown out of proportion. As always, it's crucial to separate fact from fiction, especially when it comes to matters of safety. There's more to the safety of electric vehicles than meets the eye. You see, electric vehicles hold a few advantages over their internal combustion counterparts. One of these is their weight. Electric vehicles are typically heavier thanks to their hefty battery packs. These battery packs are positioned at the base of the car, giving electric vehicles a lower center of gravity. What does this mean for safety? Well, a lower center of gravity drastically reduces the likelihood of rollover accidents, which are known to have a high rate of fatalities. It's a simple matter of physics. The weight and balance of electric vehicles make them more stable and less likely to tip over. But that's not all. The weight of an electric vehicle also gives it an advantage in a collision. Crash dynamics dictate that in a collision between two vehicles, the heavier one holds a distinct advantage. It doesn't slow down as abruptly, which is a factor strongly linked to occupant injury risks. In other words, the heavier the vehicle, the safer its occupants are likely to be in the event of an accident. But the weight and balance of an electric vehicle are just part of the equation. Most electric vehicles are relatively new models, and as such, they come equipped with state-of-the-art safety systems. We're talking advanced energy-absorbing materials and cutting-edge crash avoidance systems. We're talking upgraded seatbelt and airbag setups. All these features work together to protect the occupants of an electric vehicle in case of an accident. In summary, the safety advantage of electric vehicles is a blend of physics and technology. The weight and balance of these vehicles, coupled with the latest in safety features, collectively bolster occupant protection. The features of electric vehicles collectively bolster occupant protection. While electric vehicles have many safety advantages, they also present numerous challenges. Let's delve into the concept of crash compatibility. This term might sound technical, but it's pretty straightforward. It's all about how the characteristics of one vehicle can affect the outcome of a crash for another vehicle involved. And think about it this way. When a small sedan collides with a heavy truck, the occupants in the sedan always face higher injury risks. This is because the sedan, being lighter, absorbs more of the crash energy. In the world of vehicle safety, we measure a vehicle's aggressivity based on the level of harm it inflicts on other vehicles during a collision. Heavier models, like our electric vehicles with their hefty battery packs, are almost always deemed more aggressive. This means that while the weight of electric vehicles offers protection to their occupants, it can pose a significant risk to occupants of other vehicles involved in a collision. This presents a paradox. On one hand, the weightiness of electric vehicles offers a natural advantage in protecting occupants, but on the other hand, it also means that other vehicles bear the burden of absorbing more crash energy in collisions with heavier electric vehicles. This dilemma is central to the concept of crash compatibility, a well-established field of safety research. In addition, the increasing popularity of electric vehicles also brings new challenges. The quietness of electric vehicles, for instance, can be a risk to pedestrians and cyclists who rely on the sound of a vehicle to judge its speed and distance. The safety of electric vehicles is a complex issue that needs to be considered from all angles. It's not enough to just look at how safe they are for the people inside them. We also need to consider their impacts on the safety of other road users. As we continue to innovate and improve electric vehicle technology, it's crucial that we address these challenges head-on to ensure the safety of all road users. The safety of electric vehicles is a complex issue that needs to be considered from all angles. So, are electric vehicles safer than internal combustion vehicles? We've explored this question from multiple angles throughout our discussion today, and it's evident that the answer isn't as straightforward as one might hope. Electric vehicles have shown considerable promise in terms of occupant safety, outperforming their internal combustion counterparts in crash tests, thanks to their lower centers of gravity and hefty battery packs. The advancements in safety systems, from energy-absorbing materials to cutting-edge crash avoidance mechanisms, further enhance this protection, making electric vehicles a compelling choice for those prioritizing occupant safety. However, it's critical to remember that safety isn't a one-dimensional issue. While electric vehicles may protect their occupants better, their increased weight can potentially pose a higher risk to the occupants of other vehicles in a collision. This issue of crash compatibility is a significant one, and it's something that manufacturers and regulators need to address as the shift towards electric vehicles continues. Furthermore, we mustn't forget the burning question of fire hazards. While crash tests have not sparked any fires, and media scrutiny may have blown things out of proportion, the potential for thermal runaway in lithium-ion batteries remains a valid concern. It's a reminder that while electric vehicles are paving the way for a more sustainable future, there's always room for improvement. In conclusion, the safety of electric vehicles is a complex issue with many facets. While they offer notable advantages, they also present unique challenges that need to be addressed. It's essential for automakers, regulators, and consumers to continue pushing for safety improvements, not just for electric vehicles, but for all vehicles. As we step into a future where electric vehicles are likely to dominate our roads, Let's remember that the most significant factor in road safety isn't just the kind of vehicle we drive, but how we drive it. Let's strive to make our roads safer, not just for ourselves, but for everyone sharing them with us. Remember, safety isn't just about the vehicle you drive, but how you drive it.